So welcome back, and in today's session we continue our discussion on the basic geometrical ideas with the concept of parallel lines. Now, as the name suggests, parallel lines, literally it simply means two lines which are parallel. Now, if I want to give you an example of parallel lines, let us just take two lines on this ruled page. So let us say that we take a line number, let us say that we take this line here, okay. Let us draw it again. So we are taking this line, this is line in one, okay, that is one line, and let me skip this line and draw another line here. So these are the two lines that we have taken just on this ruled page. And now and if you remember, in order for us to identify the lines, we need at least 2 points. So let us say that this is point A on this line and this is a point B, and let us say that this is a point C, and let us say that this is point D. Now these are parallel lines. So what does it imply? Well, if you observe very closely, these two lines, no matter how far you stretch them, so if I stretch this lines from here, I'm just using a different color, and outside this, or if I stretch the other line, which is the CD, which goes outside the paper, and you can imagine as long as it can get, these lines will never meet. They will just remain at the same distance to each other. Okay, this is in the one direction, that is in the right hand side direction. Now I could do the same in the left hand side direction, that is I extend the lines beyond, that is I extended the line AB and now I'm extending the line C and D. So these lines will never meet. Now there are several real life examples where you can identify the parallel lines. The first example which I gave you is just you can take any two lines on this ruled page, they will never meet. Another thing is you can take opposite edges of a scale. Okay, so for example, if you have a scale like this, and of course I'm assuming straight lines, so these two edges, they will never meet, these two opposite edges will never meet, and similarly these two opposite edges, they will never meet, no matter how long you draw the lines. So these are again examples of parallel lines. We can say parallel line segments in this particular case. Then there are several other examples. Wherever you find lines that will never meet, no matter how far you extend them, those are all the valid examples of a parallel lines. So in order for us to define mathematically what do we mean by parallel lines, in simple words we can say that lines that do not meet are parallel lines. This is the definition of parallel lines. Now how do we mathematically represent parallel lines? So let us take our first example, which we said that okay, these are two lines AB and CD which are parallel to each other. So if these two lines are parallel to each other, we write it as line AB. If you remember, this is the representation of the line AB is parallel to line CD. This is how we represent two lines which are parallel to each other in mathematical form. If you do not want to write this long words, the capital words, to make life easier for you, we can also denote this line AB as a line L1, and this we can, the line C and D, the line CD, we can denote it as line L2. So this we can write it as line L1 is parallel to line L2. This is a more concise notation of representing the parallel lines. So this is what you can use. So we have discussed what do we mean by parallel lines and how do we represent parallel lines mathematically. Now let us continue our discussion further and understand one more concept, and that is the concept of a ray. Let's try to understand what is a ray. So in order to understand this concept, let us take a bulb. Let's take an example of a bulb. So here you have this filament of the bulb, and then you make a bulb here. I hope you get the idea. It's not a very good bulb, but now if you want to show the light coming out of the bulb, how do you show? Right? We show it through lines coming out like this. Of course, these have to be straight lines. This is how we will be showing it. Or we can take another example in which we make a flame on a candle. This is another example, a flame on a candle. Now how are we going to show the light coming out of this flame? So again, we use these type of straight lines. Now what does this mean? What does this imply? All these lines that we saw here in the case of a bulb and in the case of this, what do they imply? They simply imply that there are lines which start from this source here, this source of light, and then they extend infinitely. That is, they just go on. Similarly is the case for the light coming out from the bulb also. Now this kind of gives you the concept of a ray. So how can we define a ray? Right? You can just think of ray as a portion of a line. So that is, let me take this example. Let us say that we have a line. Let us just take a line like this. So we have this line AB. Let us call this as a line A and B. And now what I do is I am just cutting this line at this point, and the point at which this line is cut, I call it as a point O. So I have separated this line into two parts. So now what I have is something like this. So I have one portion of the line starting from O, and the other portion of the line, I'll just separate it out. Okay, it is starting from, again that has also come out from O. Okay, and the 2 points that we saw on the line, this was the point, this was the point B here, sorry for that bigger point, and this is the point A here, right? And this is point O. Actually you can make this as O dash because we have separated it, but at the moment, just for simplicity, assume that this is point O. So we have this portion of a line which starts from O and extends towards the right hand side in infinite direction. Similarly, we can call this point as O tick, O dash. It starts from O dash and it extends towards the left hand side in infinite direction. So now this is what a ray is. Right, this portion of a line, right, it has a, now if you see the difference between this line and a ray, the main difference is that it has a start point but no end point, whereas in line you neither have a start point nor you have an end point. A line just exists infinitely, it exists in till infinity, it just exists. That's the way the line is. So we can define ray as a portion of a line. You can say that ray is a portion of a line, or you can equally say that a ray has a start point but no end point. which implies that it goes endlessly in one direction. And the example that we saw is that light from candle, light from a bulb. You can also take the common example of a sun. Okay, and now how do we represent this ray? So here we have two rays. How do I represent these two rays? So we represent rays similarly as a line. The only thing is we just remove the arrow on one side. So in line, so this is line AB, and this line would be represented as AB with this, the two-sided arrows, but this is just one-sided arrow. And remember that the origin is written first. So since this is the start point, so we write O first and then B second, and then now if I want to represent this ray, right, I will write O tick A in this, because the origin point is O dash or O tick point. So this is how we represent a ray. So in this section,